హలో. సార్ నమస్కారం.
Recording in progress.
Good morning, everyone. We will start the session in a while. Good morning, everyone. A warm welcome to all the participants to the third day of the workshop on Food Analysis and Quality Control FAQC 2025 organized by the Department of Food Process Engineering and NIT Rourkela. We are delighted to begin today's session with Dr. Vivek Amamati, Assistant Professor, Department of Food Process Engineering, NIT Rourkela, who will enlighten us on detection of food additives, adulteration, and contaminants, a crucial area ensuring consumer safety and food integrity. The next session will be handled by Dr. Arun Prasad Venugopal, Assistant Professor, Department of Food Process Engineering, NIT Rourkela, focusing on microbiological analysis of foods, another important aspect of quality management in the food sector. Let's extend a warm welcome to our speakers and look forward to gaining valuable insights from today's session. So now I welcome Dr. Vivek Kambambati. I would like to hand over the session to you, sir. So please.
Thank you very much, Rashmi. Good morning, all the participants. Today is the third day for our certificate course. So today, in my session, you will be learning about the detection of food additives, adulterants, and contaminants. So in the last, 2 days, what we have learned some basics about, analytical tool. What are the analytical tools required? Right, and in the especially in the space class we learned about what are the different types of chromatographic techniques are available to measure different kinds of additives, or maybe different compounds, right? How spectroscopic will be used, what are the different spectroscopic methods are there. Okay, so here in this particular lecture, I will also be giving you some examples of determination of some additives using this chromatographic techniques, or spectroscopic techniques, right? So this is the learning objective of this particular session. What you will be learning after completion of this session, you will understand the classification of food additives. Adulteration, you will know the difference between what are the additives, adulterants, and contaminants, right? Then you will learn common detection methods. What are the common detection methods available in the food industry, and analytical techniques. Some of the analytical techniques will be using what you have learned in the last session, right? Yesterday's session. Some of the real world case studies will be discussing, and you will also be able to recognize the current challenges and emerging technologies used in this particular food additive, adulterants, and contaminants area, right? So before entering into in-depth discussion, I would like to introduce. Okay, so what are food additives, contaminants, and especially the adulterants. Okay, so why this topic is very much important. So in the last class, I discussed food authenticity. Authenticity is very much important when it comes to food safety, right? So this topic will ensure the food authenticity and safety. That will directly, that will be directly connected with the consumer trust. If you can deliver a product with safety and with a good quality aspects, then it will have a very good brand reputation, brand value. That's how the brand will get connected to the consumers, right? So trust will be created, so that repeatability in the purchasing behavior you can see in the consumer mindset. Okay, so what is additive? Additive is nothing but if you are adding anything intentionally for improving the functionality of the food component. Am I right? So for increasing the functionality of the food component, that is considered as the additives. Okay, we'll discuss in depth about all these things. Let us learn what is the basic definition of this particular thing. Adulterants. So what do you mean by adulterants? So we hear a lot of news, right? Every day milk is being adulterated, cow ghee is being adulterated, or meat is being adulterated. What is this adulteration? Intentionally, if you are adding something to gain, the economic aspect. So if you are into, if you are a businessman, if you are running any food industry. Okay, say suppose for example you have a honey processing unit. Okay, honey, you have 1 kg of honey cost around 300 400 rupees, right? Pure honey. Process, after processing, again 100 rupees or 150 value addition will be there. It will go up to 500 600 rupees. Okay, people think that 500 600 rupees, spending on 1 kg of honey is too costly. Okay, so normal people, they think before purchasing, right? They purchase 100 grams or 250 grams of honey bottles. Okay, if you add something intentionally to suppress the value of the real product, that is called as the adulterant. Okay, whereas in the case of contaminants, what do you mean by contaminants? Here there is no intentional addition, right? Something unintentionally, unknowingly happens. Okay, maybe microbial contamination, or any other heavy metal contamination. Okay, so like that, unintentionally, it is not directly added. If the crops, okay, growing on the field, which are being exposed to heavy metals, it will leach into the crops. Am I right? That if you are using that particular crop for processing, then that is unintentional. But you have to do certain tests to know how much ppm of the heavy metals are coming into the raw material. That is very much important. But sometimes unintentionally it happens, right? So these are the three things we'll be discussing today: additives, adulterants, and contaminants. Right? You can see in this picture, all this processed food look very attractive. It has lot of additives. It has a lot of humectants, texturizing agents, flavor agents. All these things are synthetic. We'll try to learn how to analyze some of the additives, adulterants, and contaminants in this particular class. Since we cannot cover the entire additive aspect, but overall, uh, some idea you will get. What are the importance of detection of these three things? First one is it protects the public health and safety. Definitely, take an example of Maggie case. What happened immediately after knowing that this particular the product Maggie noodles has heavy metal contamination? Immediately for around 6 months the factory was closed, right? So why it is closed? It is directly related with the public health and safety concerns. Then the next one is prevents economic fraud and consumer depiction. Definitely it will prevents the economic fraud. If you know what kind of contamination, what kind of adulterants are being added, you can able to analyze. Okay, you can able to quantify how much adulterants are being added. It will prevent the economic fraud, and it will also prevent the consumer depiction, right? Then next one is ensures regulatory compliance. Regulatory compliance means what? FSSAI, Codex Alimentarius. In case of spices exporting, European Union, these are regulatory firms. They lay several stringent protocols for identification of pesticide residues, fertilizer residues. So if you know these things, then you can ensure that you are fulfilling the needs of the regulatory bodies, right? The next one is maintains export quality and trade confidence. Yes, how the export quality will be maintained? I told you, right, in the case of spices, spice powders, so fertilizer residues will be there, right? Because of that, a rejection happen. So in the last class, I was discussing how much economical impact will be there if the entire lot is being rejected after shipping to the European Union. Just imagine the Indian customs cleared. Okay, it is passed every aspect of FSSA, but still European Union standards are not met. Then what will happen? The lot will come back to our country, right? So this is the here hefty amount of money is involved, right? These industries, what they do, instead of just losing it after sending the product, what they will do, they will have a quality, very good quality people in place, okay, to maintain all these quality aspects. The quality control team will be there. They will be looking after what are the additives, contaminations, what is happening with the material. They will try to identify. Some examples of consumers depiction I have given here. See here, counterfeit product. What do you mean by counterfeit? Anybody? Can anyone answer what do you mean by counterfeit product? Can anybody tell any example of counterfeit products? Yes, anything, whatever comes to your mind, you can share with us. Any idea? Anyone from the participants? Counterfeit products.
Synthetic milk.
No, any other thing? Counterfeit products. Synthetic milk. Can you give me example? Yes. Anybody? Let us discuss this one.
Substituting with lower cost products like instead of honey using corn.
Yes. Lower cost is one thing. Any other thing? Yes. Anyone else? Lower cost. This is one aspect. Any other thing?
So maybe something which is copied.
Very nice. This is the answer I was expecting. Counterfeit means imitation. Okay, imitate. Suppose sometimes you see, instead of Adibas, right? Like that, these are counterfeit. Abibas is a counterfeit product. Okay, Adidas is the trademark product, right? In the food also, you have Nestle or any kind of Britannia registered products. Okay, intellectual properties will be protected and they will have a trademark. They will have a good brand. Okay, suppose instead of Britannia, they change anything in between. Just change the name to just misguide the people, misguide the consumers, right? Those kind of products are available in the market. Around 20% market is filled with these counterfeit products. Okay, it is very much important to identify whether the products are meeting the regulatory guidelines or not. That's why we need to know about what type of additives or ingredients are being added. We need to read the label every time. Whenever we go to grocery stores, we need to read the label, we need to read the ingredients, we need to read what are the nutrients available in that particular product, whether I allergic to something or not. Okay, so similarly you have concealment, dilution products, and then mislabeling, substitution products. So many different types of consumer depiction fraud is happening. Some fruits you can see, in the milk, original type dilution, melanin will be added. In the last class we discussed, right? In the first class we discussed about the melanin adulteration, melanin adulteration in the milk to increase this protein content. Am I right? So similarly with honey, with any kind of fruits or vegetables, some kind of adulterations are being added. We need to test it properly to identify what kind of adulteration is happening, or maybe contamination is happening. Can you recall, majority of you people had this these items, right? The stick ice, or you must have had different colored candies. What is this third picture? What is the name of this one? That something I've just forgot. What is the name of this third picture? Anyone?
Sir, ice gola.
Ice gola. Yes, correct. Thank you. Thank you for telling this name. Ice gola. Everyone must have had this one, right? At least once, right? Just imagine how many colors, synthetic colors, are being added in it. If you have a very poor immunity system, okay, definitely it may convert as a carcinogenic elements also, right? That's why the permissible limit here, you do not have a control of permissible limits, right? These people, they don't go for the FSSA accreditation or any kind of accreditation. They don't follow any norms. Just their job is to attract the consumers. Once in a while, once in a year, or 2 years, if you are consuming, it's fine. You can your body is smart enough to exclude, eliminate whatever the toxic compounds are coming. But if you are having in a regular basis, once in a week, or maybe every day, definitely you can see some kind of adverse health impact in the future. Okay, so these products are very dangerous, as we assume. During our childhood days, even myself, I consume a lot of this kind of ices. Okay, so knowingly or unknowingly we are doing. If you are doing unknowingly, it is our job to educate the children. Am I right? So nowadays awareness is being created among the public. So this especially parents are very much aware of all this synthetic colors, or nowadays people are talking about preservative free. Thanks that they identified, they recognize that these particular additives are not good for health, so that there is a shift in the food processing towards non-thermal. Am I right? People, they don't want to add any kind of preservatives nowadays in the labs, right, for increasing the shelf life. All these food technology people, they just want to migrate towards the non-thermal. Am I right? So these kind of shifts you can observe. So what is the basic, the definition, literal definition of food additive? Substance added to food to improve appearance. This is just improving the appearance, right? Flavor, texture, or shelf life. Everybody says, eating a lot of sugar is not good for health. But every day we are consuming a lot of sugar in terms of processed food, right? Consuming processed food is not at all wrong, but how much you are doing it in a day? There is a prescribed limit, right? If biscuits, you can eat biscuits, but if you eat 50 biscuits at a time, definitely it is not good for your health, right? One or two biscuits, or maybe one or two chocolates, or any kind of processed food per se, I'm telling, right? So classified, these food additives are classified into natural or synthetic. In natural, you can see natural pigments, natural colors are there. Anthocyanins are natural pigments. You can add that, right? You can add that in the food materials. Synthetic colors are there, right? Synthetic colors which are not good for health. But there is a prescribed limit given by this regulatory bodies. If that limit is being exceeded, then definitely it will cause adverse health impact. That's why we need to know how much these additives are being added. This is the classification of food additives. Food additives are roughly classified into 5 different types. The first one is flavor enhancer, right? Flavor enhancer. Under the flavor enhancer, you have sweeteners, natural flavors, and synthetic flavors, right? So basically you use sugar or aspartame or any kind of 0-calorie sugars, like that, right? The next one is preservatives. In the preservatives, you have ascorbic acid. Almost all processed food have ascorbic acid, citric acid. Okay, so you need to see the label. Okay, and then benzoic acid. Benzoic acid is also being used as a preservative. Propionic acid. Okay, so sodium benzoate. All these things are coming under this benzoic acid. Fruit juices have benzoic acid. Powder, processed foods, benzoic acid, propionic acid. All these, preservatives also coming under the food additives. The first one is flavor enhancer. The second one is preservatives. The third one is textural additives or emulsifiers. Okay, textural additives, it improves the texture of the material, right? So gel, some carrageenan, and then lecithin, or monodiglycerides, these are coming under the emulsifiers. Okay, so basically what it does, sometimes there is a separation. So stop the separation of the two different liquids in the fruit juices. Okay, this particular, stop the sedimentation. You can use this gums maybe. So these are some of the textural additives. The next one is color dyes. In the color dyes, you have again two different natural colors and synthetic artificial colors, right? Can anybody tell what is IFF? What they do in our country? What is the role of IFF? Anybody? Anyone of you? IFF? Yes. Anyone?
So you're asking about industry, right?
Yes, yes,
International Flavors and Fragrance Company.
yes, yes.
They
They deal with, yes, that's correct.
Flavors.
They deal with colors, right? Synthetic colors. They have wide variety of colors. If you see, take any product, okay, the processed product available in the grocery stores, around 50% to 60% of this, colors are, taken from the IFF. It's a very, very huge company, very big company, reputed company. That's how this color dyes. Okay, these are some of the examples. Tartrazine, you must have heard about tartrazine color. Carotene is also a pigment, right? So these are This is a natural pigment. This is a artificial one. Right. The next one is nutritional additives. What are the nutritional additives? These are amino acids. Sometimes it can act as a nutritional additives. Antioxidants. If you add antioxidant, that is also an additive. Okay. If the natural presence of antioxidants are there, then that is not an additive. If you are adding more antioxidant in the food material, then that will become an additive. If you are adding vitamins, say for example, vitamin D in milk, vitamin A in milk, right? So those are additives. But these additives, some additives are good, like in milk, vitamin D. Why vitamin D is fortified in milk? Vitamin D. Any is there any reason you know in whichever state you belong
Calcium
to?
absorption.
Yes. Along with it, you have vitamin A also. Vitamin A and vitamin D fortified milks are available. Milk sachets are available in our market. Okay. So these are some of the food additive classification you can see here. These are some of the common food additives. In the preservative list, you see this sodium benzoate is widely used, right? You can see this one, sodium benzoate. FSSA has, approved a permissible limit. If you are using under that permissible limit, then it's fine. But if you are adding more, but one more thing, this one, Ajinomoto. I think most of you people heard about this one, right? It's a Japanese brand. What it does, it increases the flavor of the food material. Can anybody tell me that where this Ajinomoto or maybe monosodium glutamate is being used? Any example?
Noodles.
Yes, very good. Noodle masala especially, right? If you purchase noodle masala, monosodium glutamate is being used. It enhances the flavor. Okay. This particular monosodium glutamate is umami seasoning, right? The next one is coloring agent. In the coloring agent, you have sunset yellow, tartrazine, so many, rhodium. So different types of coloring are there. We'll discuss those things. Flavor enhancers, MSG, citric acid. Citric acid is available everywhere in the all processed foods. Okay, emulsifier, stabilizer, and sweeteners. Based on the need, we need to decide what type of food additive we need to use in our product. See how attractive this particular chocolate is. This is called as the orange candy, right? So here sunset yellow and tartrazine is being used, right? So this is the color you get, color. If you add a tartrazine or sunset yellow, this is what you will get a attractive orange colors. You can mimic the orange color, natural orange. This is the food additive category with E numbers I have mentioned here. Based on the E number, right? These are synthetic. These are not natural one. You can see if you find any E number between 100 to 199, then it comes under the colorant category, right? So you will see E numbers, right? You take if you have any processed food with you, you just take that processed food. Some E numbers are given, E324 or E414 or EAC600. Okay, you can see E numbers. What are those E numbers? These are food additives, approved food additives. Okay, that can be added in prescribed, under the prescribed limits. If you see any E number between 100 to 199, that it falls under the colorant category. Under colorant category, you have several colors are there. Between 100 to 199, you can classify, right? Then between 200 to 299, we have these common preservatives. Something like, sodium benzoate, sulfides, all these preservatives, sorbates, all these preservatives will come under the category preservatives. You can see these preservatives will fall under the number 200 to 299. The next category is 300 to 399. You can see here antioxidant, acidity regulators. It will fall under 300 to 399 category. 400 to 499, thickeners, emulsifiers, they fall under 400 to 499. You can see in the ice cream or frozen dessert, you will definitely find a E number between 400 to 499, right? Similarly, 500 to 599 acidity regulators, anti-caking agents, something like, in the Tang, Rasna, you see this E number between 500 to 599, you can easily observe, anti-caking agents. 600 to 699 is for the flavoring enhancer. All others will fall under this category. Additional chemicals, something like, if you are adding some other chemical for processing, then those things you can categorize under 1000 to 1099, right? See, analytical detection approaches. So how you can identify, we discussed all these things, right? You have 4 different approaches: chemical test, chromatographic test, spectroscopic test, and biosensor and immunomodulatory test, right? In the spectroscopic analysis, what you will do, UV spectrometry, you will create a standard first. You will do the dilution. We will see a small calculation in the little later slides, in the coming slides. So you will do this kind of, dilution, right? So you will take the standard, suppose for example, phenol, if you are identifying, you will take the gallic acid standard, you will dilute, because you know how much, dilution is happening. Accordingly, you will plot a graph, right? So if it has a linear curve, then you will take the equation y is equal to mx plus c. Then you will identify the x here, right? This y is the absorbance. We'll try to learn this one calculation. Just an idea I'm just discussing here. We discussed chromatography in the last class. TLC, thin layer chromatography, HPLC, GCMS, how you can use, how you can read the graphs and all we have seen in the last class, right? Chemical tests, these are normal chemical tests. Almost all the industries in the quality control department, they are following this calorimetric, titrimetric, all these, common chemical tests are available. These are, some of the new trends, biosensors for easy detection, immunoassays. Okay, all these things are very common. If you can see in this particular image, you have colorants, capillary electrophoresis, preservatives, immunoassay, sweeteners, electrochemistry. These are some of the methods you can identify different kinds of additives using different, instruments or different approaches. Then the first one is detection of preservatives, sorbic and benzoic acid. These two are preservative, right? It falls under category 100 to 200. Am I right? So I discussed here. See, 200 to 200 to 300 category. This sorbic acid and benzoic acid is coming under the preservative category. How you can identify? You can identify using HPLC or GC detection methods. Sulfuric acid, sulfur dioxide, not sulfuric acid, sulfur dioxide will be formed. Can anybody tell in which food the sulfuric acid will be, formed? Why the sulfuric acid, sulfur dioxide determination is very important? Any one of you?
Spoiled eggs.
Yes. Any other food? Correct. Any other food?
Onion.
Salpa, yes. Any other food?
Raisins.
Not raisins.
Product added with KMS.
Okay. This is, most common problem in shrimp, processing. Shrimp farming, sulfur dioxide, shrimp will be spoiled. Okay. So this problem, this can be, identified by using this particular method. Moner-Williams method. It is the, standard method followed for, determining the sulfur dioxide. Okay. So we'll discuss this method also. Nitrates or nitrites. Spectroscopic method, using this reagent, you can easily identify. This is the example I have given here. HPLC chromatograph for sodium benzoate, potassium sorbate, natamycin. Okay, you can observe the peaks. You can observe the peaks like this. This is the retention area. In the yesterday's class we discussed, right? In this particular retention area, using the standard, you will identify the sodium benzoate is present in your sample. If you want to quantify, what you have to do, you need to take the area. Okay. and then calculate it, and you can quantify it, how much amount of sodium benzoate is present in your sample. This particular retention time is for the potassium sorbate salts. Okay. Then the third one is natamycin. These are some of the methods you can follow. Sorbic acid estimation using HPLC. This is the the standard procedure you can follow in the industries. First one, what you have to do, if you are going with the solid food sample, then you have to take between 2 to 5 grams. The thumb rule will be 5 grams. Okay, 5 grams. Take the 5 grams of the sample and extract the sample with methanol water mixture. 60% methanol and 40% water you need to add. See why extraction is required. Sorbic acid, it will be combined with other food materials, right? When you add it in the mixing area, or maybe during mixing process, it will be mixed uniformly. This sorbic acid will be present in each and every point of the food material that you want to estimate, right? That's why extraction is very much important. Methanolic extraction is normally used for sorbic acid. This one, then centrifuge it, filter it, dilute, and inject that in the HPLC. Why this is important? Centrifugal, filter, dilute. In the last class you learned, right? In the practical demonstration, you learned that the injected sample should be clear. It should not have any kind of solid particle. It should be very clear. So what you are doing all this process, then you are injecting. Here for sorbic acid estimation, you can use this C18 column, reverse phase C18 column. In the last class, you learned how to use the HPLC using the reverse phase C18 column, right? Here we are using the same column. Using the same column, you can estimate the sorbic acid. These are the specifications of the column: 150 by 4.6 mm and 5 micrometer diameter, right? This is the specification of the column. This particular column you need to use for sorbic acid estimates. Then what is the mobile phase that you can use? Mobile phase, you have two different mobile phases, right? In the HPLC, normally 2 bottles will be kept. These are mobile phases. One is called A, the second one called B. What is A here? Water plus 0.1% formic acid. This one, right? B is acetonitrile plus 0.1% formic acid. This is the standard procedure. After doing a lot of standardization, in some research articles, they have identified this particular mobile phase combination will work. 80:20 is the best combination for determining the sorbic acid. What is the flow rate you can keep? You can keep 0.6 ml per minute. You can keep temperature around 25 degrees. The detection range 254 nanometer. Can any one of you tell which detector is being used here? Based on your last class, understanding, can anybody tell which detector is used for HPLC in this particular case? Sorbic acid.
I think it is UV.
Yes, UV visible detector is being used. Why UV visible? The 254 is UV range, right? So that's why you need to know in which band this sorbic acid curves will, the graph will come better. Then you will do all these things, 8 minutes run, all this, standard procedure. You can see here. The next one is, I told you, right, in the shrimp, the fresh shrimp looks like this. After storage, what will happen? Slowly sulfur, dioxide will be formed inside the packaging material. It will be puffed. So how to identify that one? This is the particular standard method used for identifying the shrimp sulfuric acid. Okay, Monir-Williams method, or any kind of foods you can, which forms the sulfur dioxide gas. You can use this particular method. This procedure used for determining the total amount of sulfite present in the food sample, right? Indirectly, you are calculating sulfite, then you will be correlating with how much gas is present. It works by acidifying the sample. Initially, what you need to do, you need to acidify the sample to release the sulfur dioxide gas, which is then swept by gas stream into the trapping solution. There is a one solution called trapping solution. In that, you need to release the sulfur dioxide, where it is oxidized to sulfuric acid. right? And titrated to find the original sulfate concentration. So after forming acid, right, while you're doing the titration process, what you'll do, you'll have a conical flask here. This whatever the trapping solution where it is oxidized, it will be here. The trapping solution in the using the burette, you can titrate, right? How much amount of sulfuric acid is present? It is directly proportional to the original sulfate concentration. You can identify in this method. This is basically used in the to determine the how much decomposition is happening in the shrimp. Detection of artificial colors. This is very vast topics. Vast topic. I have included few colors. So how to identify? Normally, for identifying the artificial colors. Okay. So this particular thin layer chromatography you can use for screening synthetic dyes. What kind of synthetic? You cannot quantify here. You can screen what different types of dyes are present. Okay, take for example, here you can you can use any type of instrument, but the procedure will be varied. In this particular example, this rhodamine color, rhodamine is the color, right? So it looks like this pink color. Normally it is added in the cotton candies. That's how this particular color, because of the rhodamine color only, you will get the pinkish color in the cotton candies, right? So how to quantify? You can quantify using UV spectrometer also. You can set the level between 400 to 600 nanometer. For 400 to 600, why I'm telling this is very broad range, right? If you want some research articles, they say 556. Some research articles, they say 525, right? So which one is correct? Based on the method, based on the instrument, there will be a slight variation between the the test that you are going to conduct. That's why I just I'm telling you 400 to 600. You can fix, you can screen by using the wavelength screening in the available in the UV visible spectrometer. And then this is how you will get the wavelength screening. See here, you do not know, right? If you have a sample with you, this rhodamine color, what you will do, you do not know which wavelength I need to set. That time what you will do, you will go with the screening, right? Normally from 400 to 600, 400 to 600 is mentioned. You will start the run. So slowly this rhodamine, it will be increasing like this, where it gets the lambda max. That particular wavelength you need to consider for testing this particular component, pigment, rhodamine. This is an example I'm just telling. Any color, you can identify using the UV spectrometer, but you need to know at which wavelength you can detect this color with maximum accuracy. Spectroscopic quantification of permitted dyes, and then HPLC can be used for simultaneous multi-dye analysis. So normally, these colors you can observe in this soft drinks and some of the candies, cotton candies and all, right? So this is the thin layer chromatography. In the thin layer chromatography, you have a stationary phase. On the stationary phase, these colors will be kept, and then the detector, fluorescent detector or any kind of detector can be used for getting the peaks like this. Based on the area, you can calculate. Based on the retention time, you can calculate what type of dyes are present in our sample. Rhodamine B is commonly used. And spectrometric quantification of tartrazine. Tartrazine is the commonly used E102 in the soft drinks, right? It can be quantified using UV visible spectrometer. In this particular layer, 200 to 600 nanometer, you will get a strong absorption band, especially at 427. In the 427 nanometer, you can observe the lambda max. Lambda max you will get at the 427 nanometer. Okay, but also you can consider between 200 to 600 nanometer depending on the instrument, depending on the different conditions, sample extraction and all. This is the model calculation I have showed here. What you need to do, this is the spectrometric quantification of tartrazine, right? Initially, what you'll do, you'll prepare a stock solution in water, right? Then you will make working standards. I think most of you must have done in your labs, right? The stock solution, preparation of stock solution. From this stock solution, you will prepare the working standards, right? Working standard, this you will be keeping in the refrigerator. You can use it for multiple times. The working standard you will take out, and then you will prepare the standards like this. From the working standard, you will take the, this is the aliquot. From the aliquot, you will take 0, 5, 10, 20 or 40. This is just, examples I have given. You can also take 0.2 ml, 0.4 ml. If you don't want to waste more, the working standard, you can also consider 0.6, 0.8, 1. So basically, what the Beer-Lambert law says, whatever the absorbance value that you get, this is the absorbance value, right? Absorbance value that you get, it should be less than 1. That is what the Beer-Lambert's law says. Beer-Lambert's law is applicable only when the absorbance value of any kind of sample that you are analyzing should be less than 1. Accordingly, you will prepare the standards, right? If you get value 5 for this particular standard, what you need to do? You need to do dilutions. Accordingly, you can do, right? So here you can see these are the for 0 you got this value. For 5, if you have system with you, if you have Excel with you, you can plot this numbers in the Excel. Okay, how to do that one? Can I show? Let us see whether this particular value, I will just explore that one. I am sharing the Excel with you people. Zero, 5, 10, 20, 40, right? 0, 5, 10, 20, 40. Wait a second. Zero, 5, 10, 20, 40. What are the corresponding values? 0, 0.12, 0, 0.12, 0.25, 0.49, 0.995. Am I right? If you just plot a graph, is the Excel sheet visible?
Yes, sir. Visible.
Yes,
Yeah.
sir.
This is how you will plot the graph. What you will do, you will click on the points, you will add the trend line here, and then you will ask to display equation on the chart, display R square, right? See, exactly it's coming 1. If the R square is greater than 0.99, then you can accept. Okay, if it is exactly 1, there is no error involved in sampling, right? If it is just less 0.998, 0.997 in the standards, some errors are involved. Some human error may be there, some because of the calibration. See, this is what you got. Y is equal to mx plus c, right? This is the thing that you got here. Let us check whether this is same or not. This value we can eliminate. Why? Because it's 10 power minus 5. It's very negligible and we can ignore, right? y is equal to 0.0249x. Are we getting this one or not? We have to see. 0.02498. 0. Yes. Is the slide visible?
Yeah.
Yeah. Here you can just see 0.0249 you got, right, with r square 1, which means that your standard values are very good. You can use this for calculating this tart result. Next one, what we'll do, we'll go with the sample preparation, right? We took soft drinks, some kind of soft drinks. What we will do, we will degas it by using the sonication method, or just stirring also it's possible. Gas should not be there, right? In the last video you learned in the HPLC also, degassing will be done before injecting the sample, right? If degassing will create a lot of problems, your results will be wrong. That's why degassing will be there. Then you will pipette out 5 ml sample, and dilute to 50 ml with water. Why dilution is required? Because I told you Beer-Lambert's law is applicable, below 1 absorbance value. If you are not diluting, if your sample has a lot of trotism, your values will come on top somewhere like this. Even though if the points are making a linearity, y is equal to mx plus c with r square 1. If the values are more than 1, still it is wrong. It should be less than 1 only. Then only you can consider this Beer-Lambert's law is correct. Then filter through 0.45 micrometer in the cuvettes. If you are going with the some other instrument like UPHPLC or thin layer chromatography, then this will be 0.25 micrometer filter paper you need to use, because HPLC, all these things are very sensitive, right? It has very small opening also. The column opening is very small. Accordingly, the larger molecule will get trapped inside the column. To avoid that, you need to filter it to 0.25 micrometers filter paper. Then you will take it into cuvette vials. See here, I told you the color is too intense. If the color is too intense, dilute further for absorbance, fall within the calibration. 0.1 to 1 A means this is the absorbance, is the ideal value. If you do the calculation, so you have seen these are the standard graphs from the standard, you took the working standard from stock, and then from the working standard you prepare standard solution. From this, using the standard solution, what you did, you identified the y is equal to mx plus c with r square 1, right? These are the values. Then you prepare the sample, 5 ml you have taken, you took the soft drink, 5 ml you are taking, you are going to identify the tartrazine present in your sample. So after measurement of this particular thing, you prepared a sample, you did all these things. What you got number 0.37 as the absorbance value at 427 nanometer. For tartrazine, we consider 427. At 427, the sample absorbance you got is 0.374, right? Using the y is equal to mx plus c that we got in the this graph. See here, 0.0249, the same thing, 0.0249. We took m is the slope, right? Y is equal to mx plus a, m is the slope. Concentration in the cuvette, this is we have ignored. C is equal to a by m, means this value we got. A is the absorbance value you got for the sample, 0.374 divided by, if you want to identify C, I'm just telling. Okay, what is C here? You can write it like this to, okay, avoid the confusion. You need to identify this. Okay, this is C, X is C here. This particular thing we have eliminated since the value is very minimum, 0.00005. That's why we have eliminated. Here x is equal to what? X is equal to y by m, because c is 0. We are not considering 0. Otherwise, y minus c by m will be there. 0.374 by divided by, this is the value you got from here, 0.0249, which gives you 15.04 mg per liter. This is the mg per liter, right? For per liter you got this much, but what you did initially, you did 10 times dilution. Am I right? So here 10 time dilution happened. You took 5 grams of the 5 ml of the sample and you diluted to 50 ml. So this dilution factor also you need to consider. Some people, what they do, they will stop it here. They say 15.04 mg per liter. That is wrong. 10 times you are diluting with the original sample concentration. So this value multiplied by 10 times, 150.4 mg per liter is the right quantification for tartrazine. Am I right? Am I making sense? Is it clear to everyone? Yes? Is it clear to everyone? I'm asking participants. Is it okay?
Yes, sir.
Shall I
Yes,
proceed?
sir.
Okay, thank you.
Yes, sir.
Yeah. So that's how you will determine the tartrazine. Tartrazine detection, normally it's applicable in the beverages. Extraction using the methanol you will do. Then you will use UV spectrometer. This is the cost-effective process at 427. Found exceeding limits in the unbranded drinks. Yes. Here you must have seen so many unbranded drinks, right? So in these drinks, this tartrazine will be more. Coloring agents will be more. They don't follow any kind of prescribed limitations, right? This is the color of the tartrazine. So you should not consume any unbranded materials. Detection of sweeteners. Here you have detection of sweeteners. In the sweeteners, we have aspartame, saccharin, artificial sweeteners. If you do the chromatography of these sweeteners, you will get graphs like this. For fructose, you will get like this, at this particular retention time, glucose and galactose. Different sugars you will get in the different retention times, right? This is the determination of. One more example I have given here, since I cannot give examples for everything. I have given for only few things. Okay, for aspartame using the HPLC method I have given. For HPLC, these are the specification we used. For column reverse phase, 6C18 column is being used. These are the specification. Mobile phase, we used A to B, 85:15. The A is water plus 0.1% formic acid. Astronitrile plus 0.1% formic acid is the B. We took in this proportion 85:15. Okay, volume by volume. Isocratic means what? We kept this particular 85:15 throughout the experiments. Okay, we considered 1 ml per minute. The column temperature is 25. Detection range is 215 nanometers. Why? Because aspartame strongly observed in this particular band. Okay, wavelength band. So injection volume, we injected 20 microliter. See, 20 microliter is a little excess. You can, inject 15 microliter. Whatever excess you are injecting, it will go to waste. In the last class you learned, right? The run time 6 to 10 minutes. Sample preparation, similarly, you prepare sample, degas it. Whatever you take, you have to degas if it is a liquid product. Pipette aliquot of 5 ml. Here also you are using 5 ml into a 25 ml volumetric flask. Then you are diluting it, right? 1:10 ratio you are diluting, 10 times you are diluting. You are again filtrating using this 0.245 micrometer based on the capillary. You have to decide. See here, capillary use is 5 micrometer. So 0.45 micrometer is okay. If the capillary that you are using is, very small, then we need to go for this particular micrometer range. Syringe filter to HPLC vial, that we need to take. Okay, weigh appropriately, around 1 gram of sample. then dilute it and shake it for 30 minutes. You have to mix it properly until it gets diluted. Then you inject into the HPLC, right? So before that, you have to do the standard also, right? Prepare a aspartame stock 1000 mg. So like this, 1 gram per ml, and then you just store it in the refrigerator for a few days. You can use the same thing for next analysis also, right? Prepare working standard from that, similar to the UV spectrometry. You will prepare like this. This is an example. You can do it like 0.1, 0.2, 0.3 also. At least you take 5 points to get the linearity. Otherwise, there is a chances of error, right? This is like this. The values that you got is like this. These are, this area is arbitrary units. Okay, standard for 0, 5, 10, 50, you got it like this. Then you get a slope, right? The slope, how to calculate? Area changed divided by concentration changed. From here, from the standard, if you want to identify the slope, area changed. How much area change? These are the arbitrary areas, right? 12,500 is the area, 25,000, 50,000, 1 lakh is the area, right? Area change. What is the area change from 0 to 40? How much area is changed? 0 to 1 lakh arbitrary units. Then what is the slope here? Area changes 1 lakh divided by concentration change. How much concentration is changing? 40. So you will get 2500 area units per liter. So which is falling in this category, 0 to 1 lakh. So easily you can identify, right? At which point, if your points are like this, this is 0, this is 1 lakh. Your calculated value is falling somewhere near here, 2500. This is for 0 is 0, for 5 is 12,500, for 20, 25,000, for 40, 50,000. Like this, you know, using y is equal to mx plus a, you can identify, right? You can easily find out what is the corresponding value for 25,000. This one you can easily identify. See here, if a sample gives peak area 37,500 units, concentration in injected sample, area by slope, right? Area 37,500. This is for the sample. Again, you need to understand. This is for the standard 2500 area units per mg per liter is there for standard. Then after this, what you will do? You will calculate it for the sample, unknown sample. 37,000 you are getting. This 37,000 is also falling in this line, right? Somewhere here, 37,000. Here you can easily identify by using mx, y is equal to mx plus c. Area, the same formula you have to use. Area is this much divided by slope of the standard. How much you are getting here? 2500. Area arbitrary units you are getting, right? This is the sample by this standard is equal to 15 mg per liter you are getting. Initially you diluted 10 times, so you need to multiply it with 10. So this is the final value you got it. Okay, fine. Concentration in the injected solution, you will do it like this. How much area you are getting? 37,500 arbitrary. This is the area of standard 2,500. Okay. See here, 2,500 is this one. Then similarly, detection of flavors, flavor enhancers. Flavor enhancer, using ninhydrin test. This ninhydrin test is used for detecting the amino acids. Okay. So MSG you can identify using the ninhydrin test. HPLC you can use, right, for some kind of flavor enhancements. What is the principle? Ninhydrins react with the primary amino groups. If the primary amino groups are there in the MSG, it will react with it and it will form the effervescence. Okay. The intensity is proportional to the concentration. This one we studied. MSG, glutamate ions will be there, right? Glutamate ions will be there in the monosodium glutamate. Ninhydrin reacts with all free amino acid available in the monosodium glutamate. This is best relative simple matrix. You know, for determination of amino acid proteins like that. Here in the standard, you can prepare it like this. Prepare a stock solution using the L-glutamate. Why L-glutamate? Here this MSG has glutamate ions. That's why you need to select the glutamate stock solution. Prepare working standard using this one, similar to the previous calculation. Okay, here one thing is important. For each standard, you need to do it like this. Test tube, add 1 ml of the standard and 1 ml of acetate buffer and 1 ml of ninhydrin reagent. These three things are very much important. For each standard, you need to use it like this. It means you are taking 5 mg per liter standard, add 1 ml acetyl buffer, 1 ml ninhydrin reagent. If you want to go for the sample, what you need to do, instead of standard, you need to replace the sample. That's it. It's very simple. This will be same. 1 ml acetyl buffer and 1 ml ninhydrin will be same. Reaction conditions I have given. Please go through this one. So similar to the previous this one, at 570 nanometer, you can identify this one. This is the model calculation using the same y is equal to mx plus c. Example, you got this much slope. If you find the linearity, you got this much. Intercept value also you are getting this time. So using that one, you need to identify the concentration, right? X you need to identify. Y is the absorbance value that you are getting. B is the constant. M is the slope. So absorbance you got 0.243 minus 0.003 divided by slope you are getting 0.012. This is the final results you are getting. If you are diluting, here we diluted 10 times, so multiply by 10. If you are not diluting, this is the final result. Then next one is detection of emulsifiers and stabilizers. Stabilizers and lecithin, you can use weight gravimetric method. Based on the weight you can estimate. FTR analysis you can use. What are the different functional components you are getting the FTR. Based on that you can estimate how much you can identify which emulsifier is present based on the bonding. Okay, zero stretching or any other stretching. Polysorbate, HPLC, carrageenan. Agarose gel electrophoresis is used for the carrageenan. We'll try to understand what is agarose gel electrophoresis. Agarose is a natural polymer extracted from any kind of seaweed. Okay, these are two commonly used seaweeds. From this, you need to extract the natural polymer. It forms into a gel when dissolved in buffer solution. Okay, it forms a porous network. So this particular gel porous network will be helpful in separating the molecules, right? In separating the molecules like DNA and RNA or protein-based sizes. Okay, then the pores in the gel control the movement of the molecules. So the gel is forming, right? Because of the gel, whatever the molecules you have kept on top, it will have a controlled movement under an electric field. Electric field will be placed under that. You have controlled movement with small fragment traveling larger than larger ones. So this is the picture of the agarose electrophoresis, gel electrophoresis. This is small lab technique used to analyze the nucleic acids present in the sample, right? By applying an electric field, if you keep it in the electric field, you can see here you will get a result like this. How much is being absorbed into the gel based on the sizes. 100, these are the proteins, right? 100 kilodalton, 60 kilodalton, this is the size, pore size. Okay, similarly absorption will happen. Here you can basic point, BP means basic, 765, 880 basic points. Like this you can observe the absorption is happening in the gel electrophoresis in the in the field, electric field. The rate of migration depends on the size of the molecules, allowing for effective separation and analysis. This is the basic thing. Additives compliance testing. What is additive compliance testing? Compliance means again regulatory bodies. They give maximum permissible limits and all. You can see here. Adulteration, food adulteration. What is the definition of food adulteration? Here, milk, this particular oil is adulterated, right? Which one is pure milk? Which one is, adulterated milk? We have to see. If the oil is being adulterated, you can use, different techniques to identify how the oil is being adulterated. Okay, normally virgin coconut oil is costly compared to normal vegetable oils. Okay, that's why adulteration is normal. So we can use so many different techniques. These are the classification of adulterants. Unintentional, I told you in the initial slide also, intentional and unintentional. Unintentional means you have bacteria, microbial spoilage. During processing storage, it may happen. Intentional means physical contamination, chemical contamination, and fertilizers or pesticide residues or heavy metals are possible, right? Commonly adulterated food, milk is one example, and then oil is the other example. Starch, using the starch test, you can identify whether ghee is being adulterated or not. These are simple tests, they are not 100% accurate, but still you can manage with 90% accuracy. Honey adulteration and all, right? Here, if you want to do a simple laboratory experiment, you can do it like the starch in milk, iodine test. If you get a blue color, then starch is present in the milk. Okay, methanyl yellow in turmeric. So turmeric, methanol yellow is being adulterated. You can do acid test. This one will be turning into pink. Washing soda in salt, HCl test. Okay, so these are some of the common tests that you can use it in the laboratories. Advanced tests like GCMS, all these things we have learned in the last class. What are the applications of GCMS, FTR, Raman, NMR spectroscopy and all. Then honey adulteration. Honey adulteration is very common. Okay, around 80% of the honey available in the market are adulterated. More than that, 80%. Whatever honey brand you take, it is adulterated, right? Addition of corn syrup, cane sugar, a detection by isotope. This one, ratio mass spectroscopy. You can identify using this particular isotope ratio mass spectroscopy. Authenticity can be confirmed via C13, C12 ratio. This is the carbon 13, carbon 12. The authenticity can be confirmed, especially in the honey adulteration. So milk adulteration also same thing. Urea, detergent, starch or formalin is being used as the adulterants. It can be identified by using rapid test strips are available. Adulteration kit is available for milk. HPLC can also be used for identifying the melamine quantification. Melamine is very dangerous. It will affect the renal, kidneys, right? Edible oil adulteration. 85% of oil available in the market is again adulterated. Okay. So how we can identify? We can identify using TLC and HPLC. Again, spices and color. You heard about this one, right? Recently, many brands, it has been come to the notice that all the spices are being adulterated with some chickpeas powder or any other adulterations. Lead chromate in turmeric or chilies. Okay, how you can identify? You can use, if it is a heavy metal, using the atomic absorption spectroscopy or ICP-MS, you can identify the mineral estimation. Okay, to identify the minerals, how much quantification, quantity of minerals are there, you can identify. So the last section is food contaminants. What do you mean by food contaminants? Unintentionally introduced harmful substances, right? It may come from environment, processing, packaging, storage. These are some of the types of food contaminants: biological, chemical, and physical, right? So detection of pesticide residues. Pesticide residue may come like this. From the soil, it will be leaching into the, this plant. In the last class, we discussed about Quecher's method, right? Quecher's method extraction is used for GCMS method. For spices, you have to use pesticide residues. You can use Quecher's method. LCMS for polar pesticide. Okay. The MRL means maximum residual limits. Detection of mycotoxin. For the mycotoxin, you have rapid screening tests like ELISA kits are available, and then HPLC, fluorescence detector for quantification. So many different types of detections are possible. Heavy metals, I told you, ICP, OES, ICP-MS, atomic absorption spectroscopy, mainly used for detection of lead, arsenic, cadmium, and mercury in our food sample. Okay. And one more thing you need to remember is acid digestion you need to do before going for heavy metal ICP OES estimation. Detection of packaging migrants. Nowadays, this is very important, right? So packaging, migrants means from the packaging, either from the outside or packaging, chemicals are leaching into the food. This we can identify using GCMS or volatile compounds. LCMS also we can use. This aflatoxin contamination is very common in groundnuts. So you see green color appearance are called as the aflatoxins. Okay, how you can identify by screening by ELISA method or by using HPLC method. Regulatory limits are 20 ppb given by the FSSA. If you have 20 ppb, under 20 ppb, then it's fine. If it is more, then the lot has to be rejected. Okay. Aflatoxic contamination, you can see even it can come from the animals also, because animals feed onto the crops. If crops are contaminated, then it will enter into our human, okay, leading to food poisoning. Heavy metal contamination also, ICP-MS you can use. Microbial estimation. Okay, in the microbial estimation, the next class we'll be learning how important the microbial estimation is, what are the different contamination sources, those things we will learn. The major culprits comes under the microbial are Salmonella, E. coli, Listeria monocytogen. 95% of food poisoning happens because of these three culprits. Okay, you can use the ELISA test or you can detect using normal microbial analysis test. Physical contaminants, you know this one, right? This is very small topic. Any kind of metal detector can be used for detecting the, in some kind of metals, or physical inspection is possible for glass, hair, or any plastic materials are there. Detection using some metal detectors. X-ray systems are being used. Regulatory standards, FSSA, this one we will discuss day after tomorrow. What is the role of FSSA? Codex Alimentarius. Okay, they have very stringent protocols for contaminant, toxic, and their residuals. The future perspective, you can see AML is penetrating into each and every sector. Here also for detection of contamination, AML can be used. Okay, what are the key takeaways from this particular lecture is you learned about different detection of additives. I have showed some examples, calculations. Okay, and then you understood what is the difference between adulteration, additives, and contamination. And then you learned some of the modern techniques can be used for determining the additives, right? So this is it for my topic. If any doubts, you can ask me. Otherwise, also I can take your questions in the WhatsApp. Any questions? Quick questions. Okay, in that case, I will conclude my presentation. Our next speaker is already available. Rashmi.
Sir,
Yes. You can conclude this session. You can introduce
hello.
the next. Yeah.
Uh,
Has
okay.
Arun sir joined?
Thank you so much, Dr. Thank you so much, Dr. Vivek, about the wonderful of food additives and contaminants. Your talk helped us to ensure quality and consumer safety. This is the function of the day. Up next, we have Venugopal, who will be speaking on microbiology analysis of foods, another important aspect of quality management in the food sector. Now, I welcome Dr. Arun Prasad Venugopal. I would like to hand over the to you, sir.
Has he joined?
Yes, I'm here. Just a minute. Shall we start? Am I audible?
Yes, sir. Yes, sir. You are audible, sir.
Yes, sir.
Okay. Just give me a minute. I'll share my screen. Please enable my screen sharing option. I'm not able to share. Host, can you please enable my screen sharing?
Rashmi?
Sir.
You have to enable the screen sharing option to Arun, sir.
Sir.
Can you talk to Piyush? I think you are the host, no?
Okay, sir.
Who's the host now?
I'm not the host, sir.
You ask Piyush to transfer the rights.
You can do it. Wait, sir. You can do it from your side, I think.
No,
Go to
sir. I
participant
am not
list.
the host.
Go to participant or co-host.
I am co-host.
FAQC host control 1. Who is that now? You can go to participant list. Try this participant.
I will call Piyush. I will
And
call
click.
Piyush.
So Reshmi, you can do it from your side, I think. Reshmi, go to this participant list. Click my name. You will find make us a co-host.
Piyush. Piyush. We are unable to make Arun sir as host. He is unable to share his screen. Can you do it?
Yeah.
Yes, sir. Done.
Now I'm co-host. Okay. I hope my slides are visible now. Yes. Is my slides visible?
Yes, sir. Yes, sir. Slides are visible.
Yeah. Today we'll be discussing about microbiological quality analysis of food. So I think we are good to go. Anyone from the participants? Okay, fine. So first of all, why we need to examine the food? So first, to ensure the microbial safety of the food materials, we have to perform certain microbial quality estimation to either to assess the number of microorganisms present in the food materials, or in other case, we used to do analysis to test the toxins produced from the growth of microorganisms. So this kind of examination, microbial examination, will help us to assess the safety of the food and to know the level of sanitation used during handling of food materials, right from the harvest till it reaches the end consumer. Assess the stability and shelf life of the food under normal storage conditions. So the microbial examination is performed to predict the shelf life of the commodities which is produced during a process or an industrial scale, how long will be the shelf life under an ambient condition or under refrigeration condition? And to know whether the food or the ingredients which is used in the preparation is up to the standard, and helps to determine the source, load of type of microorganisms which is present in the food materials. So mostly we do this kind of chemical analysis to know the kind of microorganism present in the food material, whether it is harmful or non-harmful microorganisms, and what is the level, what is the load of microorganisms present in the food materials. And then this examination of raw materials will also provide certain information about quantity of heat treatment required or quantity of thermal processing time required to make the food material sterile and to extend the shelf life. So first of all, we need this kind of microorganism like microbial estimation to predict the treatment or processing condition required, to know the microbial load, and to know the quality of ingredients and raw materials used, and to know whether the food material or processed food material is safe or not. So all these things, all these points shows how important a microbial estimation in reducing the foodborne illness. So as you all know, worldwide, the foodborne diseases are major health issue. So if you see, almost 3 to 5 billion cases and nearly 1.5 million deaths annually occurs due to food poisoning. And it is estimated by World Health Organization that foodborne diseases are notified in only 10% of cases. Like only 10% of the foodborne illness cases are noted or come out as an outbreak. In most of the case, rest 90% we won't report. In case of developed countries as well as in the developing countries like India. So out of 100, only 10 number of outbreaks are coming to the light. So there are almost 31 identified pathogenic microorganisms which cause foodborne illness in processed food as well as cooked food materials. So if it comes to Indian scenario, microbial population of different food varieties varies from 0 to 400 into 10 to the power 6 microorganisms per gram. You can see how bigger the problem is. Like Indian food are considered to be highly contaminated or has number of microorganisms, especially the street food, especially the food which is even in the household food, which is stored for a longer period of time in uncleaned utensils, which is processed in which is prepared and served in an unclean environment. So these things makes this Indian food materials to comes under a higher level of microbial load. The percentage of contamination of different foodborne pathogen in Indian food varies from 1 to 75%. Almost 1 to 75% of the contaminants in the present in the food materials are expected to be pathogenic microorganisms. And then salmonella is most common cause of foodborne illness in India. So we have heard about the salmonella infestation recently also in case of hotels where the food safety officers used to go for raid and they catch chicken, like stored chicken which is stored for a longer period of time, or cooked chicken stored for a longer period of time. So all those things are salmonella infestations. They expect salmonella infestation, so they try the food materials. And this chart you can see before COVID-19, and even now we can see in 2020 also, we have a huge number of the major disease in Indian condition is acute diarrhea and food poisoning, which is next to chicken pox and other dengue, cholera, malaria, those things. So food poisoning and diarrhea are major cause of foodborne illnesses in India. These are some of the important foodborne pathogenic microorganisms which we come across every occasion in Indian food materials. So some of these are categorized as toxogenic and enteropathogenic. I will explain you this enterotoxogenic and enteropathogenic. These are some of the microorganisms which causes toxins, which produce toxins, and the toxins cause illness in human after conception. This especially this aflatoxin producing Aspergillus species, and then Bacillus cereus, and then example for this enteropathogenic, we have this Salmonella, Clostridium perfringens, and Listeria monocytogenes. So these are some of the important pathogenic microorganisms which cause foodborne illness in human consumption, when the food is infested, food is consumed with the humans. And then there are some viruses also. There are this hepatitis, rotavirus. There are some viruses which also contaminate the food materials and transmit through the food and water. So it is the combination of attributes or characteristics of the product that have significance in determining the degree of acceptability of the product to the user. So whether the food material is microbiologically safe, and how to assess the quality of the food materials. Either we should go for testing for microbial analysis. So we go for bacterial count, or in prepared food and water, and with a key factor mentioning that number of colony forming unit, or plate count method, or streak plate method. There are n most probable number method. There are so many methods which we will be discussing in the following slide. So refers to the level of occurrence of microorganisms in the final products. Like what we are ultimately producing is we have to ensure that the presence of pathogenic microorganisms in the finished product is nil. So if you see why microbiological analysis of food material is important, one of the most important reasons for analyzing the food from both the consumer end and manufacturing end and it is to ensure the safety of the consumers, like either immediately after processing the food material, or before consumption, or before processing the raw material. In all the stage, we have to ensure and eliminate the pathogenic microorganisms. Depends upon the load, as I said in the previous slide, depends upon the microbial load present in the food materials. It aids the processor to design the processing parameters accordingly. It can eliminate such a disease-causing microorganisms during the process. So food may be considered to be safe because it contains harmful microorganisms like Listeria and Salmonella. Unsafe, like when there is a presence of E. coli, Listeria, Salmonella in food materials, it is unsafe. The food contaminated with pathogenic microorganisms are very difficult to identify. So this is one of the important reason where people fall ill with food, these pathogenic microorganisms. Like it doesn't taste bad, or it doesn't smell bad. So it is very difficult to identify the contaminations or the presence of microorganisms in the spoiled food materials. So the diseases that results from contaminations are two types. Majorly two types can be classified. That means the food poison. Food poisoning can be classified into two types. One is intoxication and infestation. Intoxication is the enterotoxogenic, like when you the disease or the illness is caused as the effect of consuming the toxins which is produced by the microorganisms. Even though the microorganism is destroyed by heat or cooking or some other method, the toxins may remain in the food materials and it cause illness. So it's example our aflatoxins, which is present in the food materials, or maybe some other toxins which is produced as the metabolic residues of microorganisms remains in the food materials. And whereas the foodborne infection is caused by the microorganism itself. When you consume the microorganisms, it enters into the intestinal tract and it causes infections in the human body, and it's responsible for producing toxins inside the body and which cause illness. So most common symptoms associated with this foodborne illness is diarrhea. Immediately, the first symptoms we come across is diarrhea, followed by there are even up to paralysis. There are so many symptoms. Methods for microbial analysis. There are so many. Actually, the methods for microbial detection. We can categorize into two types. One is quantitative and qualitative analysis. Quantitative, we mostly prefer it to know the microbial load in the food materials, especially raw materials. When you receive the raw material for processing, first we go for quantitative analysis and ensure and enumerate the number of microorganisms or microbial load in the raw material. And during processing, what are the processing conditions to be followed, adapted to eliminate the load of microorganisms present in the food material. Whereas the quantitative analysis, mostly from a food safety point of view, to know what kind of microorganisms, qualitative, what kind of disease causing microorganism present in the food materials. E. coli, Salmonella, Staphylococcus aureus, and then the Clostridium perfringens, and then Listeria monocytogenes. So mostly Clostridium botulinum, and what kind of microorganisms. It varies, depends upon the type of microorganism. The detection techniques may varies. Whereas this quantitative, either we go for aerobic plate count or yeast and mold count. So these are some of the methods available for analysis. We will be seeing one by one. Before that, there should be some precautions during sample collections. The sample, like consisting of specified number of sample units, should be drawn at a random from a lot, or each sample unit shall consist of at least 100 ml or 100 grams of sample. Collect the original unopened container wherever it is possible in the original conditions, and keep the sample refrigerated or frozen 0 to 4 degrees Celsius, depends upon the nature of the product. The sample should be examined as soon as possible when it after sampling. So these are some of the precautions to be taken during microbial sampling and examination. We'll see some of the quantitative analysis analytic technique. So first, as I said, the aerobic plate count. This is the most common method we use to know the number of microorganisms or microbial load. This method is applicable to enumerate the viable aerobic microorganisms, under all the conditions like Psychrophilus, Mysophilus, or thermophilic bacteria in food. The procedure goes like this: mix 10 grams of sample into 100 ml for maximum recovery diluent, and then prepare a serial dilution of 10 to the power -1, 10 to the power -2, 10 to the power -3, and 10 to the power 4, or even 10 to the power -5. So to reduce the microbial load, and inoculate 1 ml of each dilution into a plate, like the plate count agar. Mostly we go for agar medium, or potato dextrose agar medium, or rose bengal agar medium, and incubate it at 30 degrees Celsius for 72 hours. After 72 hours of incubation, we can go for counting the colony forming unit. This is an example of a microbial plate which show bacterial growth on plate count agar. So the serial dilutions, you can see initially this in 10 ml of 1 ml of sample in a thoroughly mixed sample in case of 10 ml, and then from 10 ml, 1 ml from this 10 ml will be goes into the next tube in a series of dilution technique. You can reduce this number of 1:1 lakh, and then if you go for 1 ml of this final serial diluted tube into a plate, and it gives incubated for a certain period of time, and then depends upon the condition, climatic condition, the incubation, and then we finally go for plate count after 72 hours. So there are 3 levels of aerobic plate count based on type of food and processing. or processing technique which is undergoes. For raw material, for finished product. Level 1, which is ready to eat food, like our pizza, cookies, ice creams, and pasteurized milk, and then like sandwich, soup, meat sausage, fish sausage, vegetable sausages. It's the food in which all components of food have been cooked in a preparation of a final product. So the first category is all the food materials, all the ingredients in the food is cooked at for a certain period of time. So in that case, the quantity, the microbial load will be less. Whereas the second thing is, even some portion of the food materials are cooked, whereas the some portion which is used to garnish or used as a filling or used as a stuffing, sorry, which is sliced and mixed and stored for a certain period of time, has some more microbial load. And then the third level is the raw materials, which doesn't involve any thermal processing or cooking preparations. So in such case, this Arabic plate count may not be applicable because of the higher microbial count. And then the next thing is yeast and mold count. This method is applicable to enumerate the viable yeast and mold in the food and food ingredients. It may be also be used to confirm the viability of yeast, mold, or spores present in the food materials or in the surface of the processing equipments or utensils or in the packaging materials, whatever. So both yeast and mold cause various degrees of deterioration and decomposition in food. And then especially this toxin producing fungal infestations like aspergillus, penicillium, and then aspergillus flavor, mycotoxin producing and aflatoxin producing fungus. They are involved in different forms of diseases and including allergens to fungal antigens, production of toxins, and direct invasion into the host. So this is the plate of yeast colonies. Usually, it will be characterized by smooth and moist, elevated colonies. And this is some of a plate which shows the mold colonies, which are easily recognized by the profuse growth of hyphae and fibrous structure, or this filamentous growth. You can see bacillus flavors from tomato, and then aspergillus from tea, and some more mycotoxin producing of aspergillus from rice. So the procedure is similar. Take a sample, we go for dilution, serial dilution, and inoculate it in a correct medium. Like here we use a CYGA medium, which is most suitable for fungal, this mold growth, and incubate it for 25 degrees Celsius, 3 to 5 days. Whereas in case of bacterial infestation, bacterial plague, Arabic plague count, we go for 72 hours. In case of mold and fungus, we may wait up to 3 to 5 days to get the colony forming unit. And elimination of yeast and mold count of beverages and ready to eat food. So you can see apple juice, yeast and mold per gram or per ml, like 15.72 colony forming unit. Like the limit is not more than 2 colony forming unit per ml. So aloe vera juice and tomato ketchup, like it is 25.64 when it is evaluated in Indian conditions. Like the limit says it should not be more than 2.2 colony forming unit per ml. So bread like shall be absent in 0.1 gram of product. Like it may go up to like point even less than that. So bread, dried lemon, white rice, atta. So these are some of the um, product tested results of the product tested, which is available in literature. And total coliform count. This is another microbial examination where most of the raw materials are undergoes, like especially which is harvested from farm or procured from a farm. Total coliform bacteria are commonly used a bacterial indicator of sanitary quality of the food and water. So how far the sanitation practices and the good manufacturing practices are followed in the production process. This indicates that the presence of coliforms indicate that the sanitation practices followed or the manufacturing practices followed is not adequate. So procedure same mix some 10 gram of sample, like prepare 10 gram of sample and thoroughly mix with 90 ml of water and prepare cereal dilutions and inoculate in violet, neutral, red bile lactose agar and incubate it for at 37 degrees Celsius for 24 hours. We can see and colony forming unit like this, and we can go for counting of number of colony forming unit from this. So these coliforms are rod-shaped, gram-negative, non-spore forming, and motile and non-motile bacteria, which can ferment lactose with the production of acid and gas when it is incubated at 35 to 70 degrees, 37 degrees Celsius. So these are the number of commonly forming unit present in the samples like ice cream, fruit juices, and corn syrups. These are very higher level. And the number of colony forming unit, one colony forming unit, the confidence level, like 95% is less than one, like up to 3 colony forming unit is less than one, and then the confidence level shows with number of colony forming unit in the table. The next is qualitative analysis. So for this plate count method, all these things are quantitative, and then this qualitative analysis, it depends upon the individual microorganisms. So microorganisms are responsible for food poisoning or foodborne illnesses. Has to be listed down first, like our E. coli, Salmonella species, and Staphylococcus aureus, and Clostridium perfringens, or Clostridium botulinum, or Listeria monocytogenes, Shigella. All those has to be listed, and there is separate process for each and every microbial examinations. Like the first one is E. coli. It's a gram-positive, non-sporulating, facultative anaerobe, which is present in the low intestinal tract of human body, human intestinal tract, as well as warm-blooded animal or bird. So the presence of E. coli indicates the contamination with any fecal matters of animal, human from any uncontaminated water. So contaminated water. The pathogen of primary concern is E. coli U157157 is the strain which cause sugar toxin producing E. coli. So this is and then this sugar causing very harmful when you consume it, cause food very high rate of diarrhea and higher rate of food poisoning occurs with this E. coli. And E. coli at 44 degrees Celsius in McKenzie broth medium and positive with acid and gas production. So when you go for cereal dilutions and leave it in the McKenzie broth, it shows gas production, which indicates the presence of E. coli. And the E. coli shows metallic shiny colonies on EMB agar medium. And the procedures like 25 gram of sample plus 200 ml of 1% peptone was taken and homogenized properly and transferred this in transfer 10 ml sample plus 10 ml MB, that is methyl blue medium, and then incubate it at incubate all the inoculated medium at 35 degrees Celsius overnight, and then this methyl blue agar, the medium, the methyl blue medium is positive, then transfer to the agar plate, and we can see the colony forming unit. So E. coli produced ink colonies surrounded by a zone of acid precipitated bile on Mackenzie agar, and E. coli produce yellow colonies with yellow zone in 0.07. Salmonella, the next one is Salmonella. The Salmonella is a rod-shaped, generally motile, non-spore forming gram-negative bacterium. The Salmonella are considered among the most important foodborne pathogenic microorganisms. Like this Salmonella infestation is often concerned in raw meat or even eggs, raw meat and poultry products. Salmonella is heat and acid sensitive. This Salmonella not only serves drying, but also became more heat resistant during the drying process. And more often, the issue is it is non-fermented dried meat, and then the whole meat stored under refrigerated conditions for a longer period of time in a frozen refrigerated storage conditions, and where the chance of salmonella infestation is very high. Many outbreaks of human illness have been associated with this consumption of raw, inadequate, heat-treated milk and dairy product and poultry product as well. So who can get salmonella? Like one can get salmonella from eating variety of food. Salmonella can be found in variety of food, including chicken, vegetables, which is grown with the animal like animal waste as a fertilizers, vegetables like root vegetables, egg, fruits, sprouts, beef, pork, unprocessed raw meat, even from milk. And then the salmonella is a type of food poisoning. Salmonellosis is a type of food poisoning caused by salmonella bacterium, and every year this salmonella is estimated to cause 1 million foodborne illness. In case of United States, and in Indian conditions, we often don't report this salmonellosis. Like still, it is more than this. The report more than 1 million to 2 million foodborne illness occurs due to salmonellosis. And then the procedure to identify the salmonella in food materials, like 10 grams of samples in 25 grams of sample plus 225 ml of buffered peptone water, and then is mixed well and incubated at 37 degrees Celsius for 16 hours. Like after incubation at first selective enriched RV medium, it turns like the color change occurs, and then the salmonella appears as a red to pink white colonies surrounded by the red zone in brilliant green agar medium. You can see this presence of salmonella's colony forming unit, and then the salmonella appears as a pink with white with black center in xylose agar medium, and then the salmonella produce black colonies in Smith sulfate agar medium. So it depends upon the medium and depends upon the source of salmonella infestation. And then the salmonella generally shows the reactions given in the following table, like biochemical just positive, different types of tests. You can see TSI glucose, that is triple sugar ion glucose test for acid formation, gas formation, lactose, sucrose, and hydrogen sulfide productions. Like it gives positive results in case of acid formation and gas formations and hydrogen sulfide production, and negative in case of lactose and sucrose. And the next microorganism of interest is this Staphylococcus aureus. This Staphylococcus aureus is a gram-positive bacterium which appears in cluster resembling grapes. You can see this is the picture which is shown above. Like when you under microscopic observation, you can see a cluster of microorganisms resembling the grapes, and it is non-motile, non-spore-forming facultative anaerobe that can grow with or without oxygen. That is the meaning for this facultative anaerobe. And source like meat and meat product, poultry and egg products, it became a problem when competitive microbes are removed by cooking or inhibited by high salt. So this Staphylococcus aureus we can found in pickled vegetables and pickled meat, where the competitive microflora is completely eliminated, and it should not be detected in 25 grams of any type of food materials. If it is detected, considered as potential hazard and may result in foodborne illness if consumed. So this is the procedure: 10 grams of sample plus 90 ml of 1% peptone water was taken and homogenized properly, and then 10 ml of liquid was transferred into a cooked salt medium tube and stick on a BPA plate, like BPA agar plate, and we can see this BPA plate. You can shows black color colonies in a plate and black color colony forming in a streak plates, and incubate at salt medium at 37 degrees Celsius overnight, and the inoculum in a BPA medium at 37 degrees Celsius at least for 30 hours. You can see the growth colony forming shows. And then the next thing is Clostridium. The next microorganism is Clostridium perfringens. Is an aerobic gram-positive rod and rod-shaped bacterium, and it can produce lecithinase on egg yolk medium, and the mostly cooked meat which is stored for a longer period of time, cooked beans, dal which is stored for a longer period of time, and then the mixed cell count greater than 10 to the power 8 is mostly considered to be unsafe, and it should not be detected in 25 grams of any type of food materials. If it is detected, and it is considered potentially hazard, potential health hazard, and mostly vegetative cells are killed by heat processings. The presence of Clostridium perfringens in the processed food material source the chance of cross contamination. So this is a procedure to be followed to identify this Clostridium perfringens. Like 25 gram sample in 200 ml 1% peptone water was taken and then homogenized, and 10 ml of this solution is transferred to a cooked meat medium tube. This cooked meat or meat broth, and inoculated overnight at 37 degrees Celsius. This lecithinase is a type of phospholipase that act upon this lecithin, which is produced, which lecithinase is production on egg yolk medium. We can see this lecithinase production, a positive lecithinase test noted by noted with this white opaque diffuse zone that shows the presence of Clostridium perfringens. And then the Listeria monocytogenes. This is also a disease-causing microorganisms. The procedure adapted to identify this Clostridium perfringens, this Listeria monocytogenes, is 25 gram of sample, like 225 liter of half pasture broth was taken and then properly homogenized, incubated at 30 degrees Celsius for 24 hours, and then the turbidity is observed, then transferred to the plate. We can see greenish colony which is produced with the black halos and in Oxford agar medium. when it is incubated at 37 degrees Celsius for 48 hours. Then, so these are the qualitative analysis based on different microorganisms, and in following slide we will be seeing some of the important microbial analysis of water. So why this microbial analysis of water is important? So health and survival of man and other organism depends upon the water and purity of water they drink. So mostly, in most of the case, water is the source of microbial contamination, and water is the source of spreading of microorganisms in a society. So water, so different measures are used to access the quality, control water quality with varying degrees of relevance and acceptability. So we go for water treatment, we go for in-home this RO treatments or filtration treatments to increase quality of water. Till how this water quality can be analyzed, like physical by turbidity, by measuring the turbidity and measuring the impurity, and chemical by measuring the COD level and BOD level and all those things. Whereas the microbial quality of the water can be often evaluated by this microbial analysis. Most sensitive test for the detection of recent and potential dangerous fecal population, and then and the hygienic condition of the water, and then the quality of microbial water can be obtained by serial dilution techniques. And the quality of water, the quality of water is identified by some indicator organisms. So presence of E. coli, presence of coliform, total coliform can give us the quality of water, and then the total coliforms. The gram-positive rod-shaped bacterium that are found in soil, in water, and that have been influenced by surface water and in human animal waste. Not necessary to be a fecal bacterium, but the coliforms which is present in the soil and surface water, groundwater. Quality can be estimated by estimating this total coliform, and then the fecal coliforms are the group of total coliform that are considered to be present specifically in the gut of warm-blooded animals. So that shows the contamination with fecal matters. And then this Escherichia coli, that is E. coli, is a major species of fecal coliform group. E. coli is generally not found in the growing or reproduced in the environment. So definitely the presence of E. coli indicates the contamination of some fecal contaminations. So sampling technique, as you all saw, the sampling from the tap or pump outlet, recover from any water sources, and can be analyzed. Methods of microbial analysis of water. There are some few methods which shows the presence of coliform, E. coli, or total coliform, to enumerate the total coliform. Multiple tube methods. The most probable number, that MPN method, is applicable to enumeration of coliform or fecal coliform or E. coli in food as well as in the water, like set of double strength Meckenke broth tubes. And then the presentative test, like after 24 to 48 hours of incubation in this Meckenke broth tube, both single strength and double strength. Like this is the single strength and double strength Meckenke broth tube shown here. Confirmation that the positive tube from this presentative test were taken and then inoculated into BGB tube, that is a brilliant green agar tube. For 48 billion green, or about 48 hours of incubation at 37 degrees Celsius were observed, and then the completed test after streaking into a plate. You can see agar Meckenke agar plate where incubated at 37 degrees Celsius for 48 hours shows colony forming unit like this. And this coliform in this brilliant green broth tube, we can see collection of gas as an indication. And then fecal coliform test, you can see a positive tube from a representative test where it is inoculated at 44 degrees Celsius, 44.5 degrees Celsius for 48 hours. And then you can see this peptone water tube changes. The changes are shows a red colored ring, which is indication of positive iron test. That is E. coli present in this tube, whereas the non-E. coli negative tube shows the red color, green color. So typical sample need to be tested almost for the drinking water or potable water. 5 repetitive samples has to be tested. And even it shows like in most probable numbers, 0 combination of positive tubes and negative tubes. If it is 0, 0, 0, then it's safe. And then this when it is increased, when the coliform, where the positive tubes number is increased, we can show the results in this table. 95% confidence level increases. And this is the guidelines of bacteriological quality of drinking water. All water intended for drinking must not be detected in any E. coli, any form of E. coli in 100 ml of sample. Whereas the treated water entered into the distribution system mostly must not be detectable in any 100 samples, like 100 ml samples. E. coli are thermotolerance coliform bacteria and total coliform bacteria. And then the treated water in the distribution system, the E. coli and the thermotolerance coliform bacteria and total bacteria must not be detected at any 100 level sample. In case of larger water supply, where the sufficient sample need to be examined, must not be present in 95% of sample taken through period of 12 months. So this is the guidelines for any water quality estimation. So that's all from my side. These are the different methods of microbial examination in case of food materials as well as water. We have discussed right from this qualitative analysis and quantitative analytic technique used for detection of microbial quality of the food materials as well as water. Thank you so much for listening. If there is any doubt, please go ahead. Or you can, I think the participants, if you raise your hand, we can unmute you. Or you can type your questions in chat box. Okay, if there is no questions, please, Rishmi, please close the section.
Okay, sir. Thank you so much, Dr. Arun Prasad Venugopal, for the highly informative session on microbiological analysis of foods. Your insights have truly helped us to understand the importance of microbiological safety and hygiene in maintaining the overall food quality. With this, we come to the end of the second and very enriching session of the day. Thank you all for the active participation and attention throughout. We will now take a short break before moving to the next part of today's program. Please make sure to join us at 2 p.m. for the next insightful session of FAQC 2025. We look forward to seeing you all there. Thank you.